we have some new images of TR and ATLAS, the third interstellar object ever recorded. But ATLAS is moving toward the Sun. There is still so much we don't know. On July 1st, 2025, NASA confirmed that a third interstellar object had entered our solar system. We must check each visitor that arrives, but its tail wasn't trailing behind. It was pointing toward the Sun against every known law of physics. And now scientists are asking, is it really a comet? The Discovery on object traveling at 130,000 miles per hour began as nothing more than a blur, a moving dot of light in a sky scanned by the Atlas Observatory in Chile. The date was July 1st, 2025. At first glance, it seemed like just another frozen visitor from the distant reaches of the solar system. But then came the numbers. Its speed was measured at more than 209,214 kilometers per hour, far beyond the typical velocities of comets bound by the Sun's gravity. Its trajectory was nearly a straight line, with an eccentricity greater than 6, marking it as undeniably interstellar. It wasn't a fragment from our solar system. It was a traveler from another star. NASA released its conclusion within hours. The object was officially designated 3IATLAS, the third interstellar object ever observed after ʻOumuamua in 2017 and Borisov in 2019. But even among these cosmic rarities, ATLAS was different. Its trajectory sliced neatly across the plane of the solar system, retrograde, and almost perfectly aligned with Earth's orbit. Statistically, such a coincidence had less than a 0.2% chance of occurring randomly. Veteran astronomers frowned, and then came the images. What they revealed wasn't just strange, it was impossible. As telescopes around the world zoomed in, one disturbing feature became clear. The object's tail wasn't trailing, it was leading. The impossible tail, a plume directed straight at the Sun. In every astronomy textbook, comet tails obey the same rule. They always point away from the Sun. That happens because sunlight, specifically radiation pressure, blows dust and gas backward, like wind catching a scarf in a storm. But ATLAS refused to play by those rules. Days after its discovery, NASA released high-resolution images showing something bizarre, a bright, persistent plume emerging from the sunlit side of the object, aimed directly at the Sun. In a press briefing, veteran comet scientist Dr. Bryce Bowling described it as bulbous, defiant, and sunward. Other astronomers were more direct. This should not be happening. Multiple observatories confirmed the anomaly. The Gemini South Telescope in Chile and the Lowell Discovery Telescope in Arizona both captured the same sunward plume. It didn't flicker. It didn't shift. It held steady for days, and its structure resembled nothing in cometary science. The dust appeared far too heavy to be pushed by the solar wind, yet it also didn't fall back toward the nucleus. Instead, it advanced, holding its shape like a narrow, concentrated jet. Teams run simulations, adjusting for dust size, solar wind pressure, rotation rates. Nothing explained what they were seeing. Every model failed. For centuries, comets followed the rules of physics. Hale-Bopp, Borisov, all obeyed the Sun. ATLAS did not, and that single fact forced scientists to consider a possibility no one wanted to say aloud. What if the plume wasn't just dust? What if it was something being propelled intentionally? Chemical clues soon deepened the mystery. In early August, NASA pointed the James Webb Space Telescope at 3IATLAS. Its mission to analyze the reflected and emitted light from the coma, the halo of gas and dust surrounding the icy core. What Webb found shocked even the most experienced cometries. The spectrum revealed a carbon dioxide to water ratio of 8:1. That number alone broke the rules. In almost every known comet, water dominates. Carbon dioxide, when present, usually plays a secondary role with ratios between 0.1 and 2. A few rare cases had reached 4, but 8, that was off the scale end. It wasn't an error. Chile's very large telescope confirmed the data. Not only was carbon dioxide dominant, it was concentrated exactly on the sun-facing side, precisely where the mysterious plume originated. Even stranger was the detection of atomic nickel being ejected in massive amounts, more than 1,022 atoms per second, a rate rarely seen even in the brightest comets. But iron was missing in our solar system. Nickel and iron almost always appear together. Here, nickel was erupting without iron. The implications were staggering. This object didn't just come from another star system. It likely formed in a radically different planetary nursery, where carbon dioxide was more abundant than water and nickel could vaporize independently of iron. But its origin wasn't the only question. If carbon dioxide was driving the plume, the next question was simple. Was this propulsion or sublimation? Comets usually move because sunlight heats their surface, turning ice into gas in a process called sublimation. The escaping gas pushes the comet gently in the opposite direction. It's passive, predictable. But Atlas wasn't passive. Its sunward plume was too focused, too narrow, too persistent. It didn't spread like typical sublimated gas. It advanced like a rigid column, holding its shape against the relentless solar wind. That's when a controversial idea emerged. Propulsion. Enter Dr. Avi Loeb of Harvard University, no stranger to cosmic provocations. He pointed out that Atlas's plume resembled the exhaust of an ion engine, the same technology NASA uses to push probes through deep space. Ion thrusters don't explode like rockets. They use electric fields to expel charged particles in a narrow flow, producing steady thrust. And if you were a probe arriving from interstellar space, you'd need to slow down. The most efficient way. Turn your engines toward the sun, fire near perihelion, and exploit the Oberth-effect physics trick where burning fuel at maximum speed near a gravity well gives the greatest return. That was exactly the orientation of Atlas's plume sunward. Focused, constant. Critics argued exotic ESOS, or rotational geometry, could explain it. Maybe supervolatile patches were erupting. Maybe it spin aligned just right, but none of the sublimation models reproduced the shape, the thrust, or the persistence of the plume. The scientific community split. Was this a natural comet behaving on something attempting to maneuver? Orbital data soon weighed in. By mid-August, astronomers tracking Atlas noticed something disturbing. Residual tiny differences between predicted and observed positions were growing. They weren't random, they were directional, always pushing toward the sun, aligned with the plume. A team at NASA Jet Propulsion Laboratory modeled a non-gravitational acceleration, a tiny sunward push of about 4 meters per second squared, minuscule weight of a feather pressing on your hand. But in space, over time, it adds up. And critically, that thrust matched what an ion engine might produce. The echoes of ʻOumuamua returned. Back in 2017, ʻOumuamua accelerated mysteriously without out. Some called it a hydrogen iceberg. Others invoked exotic physics. But Avi Loeb proposed a radical idea. What if it was artificial solar sail sent from another civilization? The claim sparked controversy. But one truth remained: the data didn't fit the textbooks. Then came Borisov in 2019, a classic comet restoring a sense of normality, but Atlas shattered that comfort. It had a tail but pointing the wrong way. It had gases but in the wrong ratio. It accelerated but in the wrong direction. Atlas also followed a disturbingly precise path. Most interstellar comets arrive chaotically on random, tilted trajectories, but Atlas entered neatly, aligned within just 5 of the ecliptic plane of Earth's orbit. The odds of that happening by chance, less than 0.2%. And then came its planetary encounters. Simulations showed Atlas would pass near Mars in October, Venus in November, and Jupiter in March. Not dangerously close, but close enough to raise eyebrows. The chance of an interstellar object passing sequentially near 3 planets, less than 1 in 20,000. Such precision blurred the line between coincidence and design. If Atlas was launched into our system, it didn't just aim for the sun, it chose the scenic route, a deliberate sequence of planetary flybys, and now it was heading for the blind spot. On October 30th, 2025, Atlas would slip behind the sun at perihelion, its point of closest approach. At maximum speed, under peak solar gravity, it would vanish from every telescope on Earth. If it altered course, fired engines, dimmed, or flared, we would never see it. Solar conjunction isn't just a blind spot, it's the perfect cover. Orbital engineers know this moment well. It's when spacecraft perform critical burns hidden from observers. If Atlas were under propulsion, this would be the moment to act. NASA and ESA teams scheduled reacquisition scans for when Atlas reemerges weeks later. They'll be watching for the slightest deviation in its position, trajectory, or brightness. Until then, Atlas is untouchable, a mystery sealed behind the brightest light in the sky. Right now, 3IATLAS drifts behind the sun, silent, unseen, and possibly moving. When it reappears, the numbers will tell the truth. Until then, we wait knowing the universe has just handed us an enigma that may not be natural and may not be alone.